this video, we're going to go over how to translate a word problem into a slope-intercept form of the equation of a line. Then we're going to graph it just to model the situation. Let's dive right into it. So this reads, you begin working at a music shop and must buy $40 worth of uniform shirts. So maybe they're collared shirts that have the name of the music shop on them and you have to pay for them. You earn $10 per hour. Oh, sweet. Write and graph the equation that represents how much money you profit from working at the music shop. Just quick side story or note is that profit means how much you'll make on top of what you lost, right? For the $40 worth of uniform shirts. So that includes the $40 loss. So if you make $70 in hourly wages, but have to pay $40 for the shirts, you've profited 70 minus 40 or $30. That's a big hint. So how do we translate this? Well, first things first, we've got to define the variables involved here. The first thing that I know is the amount of hours that we work is a variable. It's changing. So I'm going to let x, just because we're used to using x's and y's, equal number of hours worked. And I'm abbreviating that. Your teacher might not like abbreviations, but I'm abbreviating. Then we'll let y be the output, and y will be our total profit. So the amount of money we've made. So we'll say money made. Okay, so how do we relate all these? Well, as I'm reading, I'm getting a general picture of how to translate this. If you're earning $10 per hour, that sounds a lot like slope. Indeed it is. So $10 for each hour worked. But after making however much money, because this represents the money we make on hourly wages, we're losing 40 bucks off of that. Just once though, so that's a constant minus 40 that we've lost. Nice. And that's it. But it's equal to the total amount that we profit y, right? The money that we've made. So we generate the slope-intercept form of the equation by, as we normally do with word problems, translating as we read. Sweet. All we have left to do is to graph y equals 10x minus 40. And then we'll have a graphical representation of this situation. Let's do it. So I'm going to have the axis go by tens here. So I'm just going to write down negative 20, negative 40, and then we'll go up 20 here. So I'm going up by tens, but every 2 blocks I'm putting numbers. 80, and then I'll stop at 100. Perfect. And then each of these can go by ones, right? So this would be 2, 4, 6, 8. There we go. So the x-axis is hours, the y-axis is the money that we've earned, and that looks like a 6. Trust me, it's a 0. So we've picked out our intervals. Now we've got 10x minus 40 to graph. Our y-intercept is at negative 40, so we'll plot that like we know how. Bam! Then we're going to slope it up, where we go up 10 and over 1, or go and increase $10 for every 1 hour worked. $10, another hour worked. $10, another hour worked, up 10 over 1. And after 4 hours, we've just broken even, which makes sense because it takes us 4 hours times 10 is 40 bucks. That's paid for the shirts. Then up 10 over 1, up 10 over 1, up 10 over 1, and so on and so forth. Now, I'm only going to start my graph, it's very important to recognize this, at the y-intercept because there is no negative time. You didn't start working there before you started working there. That's just weird. That's it, peeps, and we can use the graph for a number of things. I could say, use the graph to figure out the profit that you've made by working at this music shop after 8 hours. Well, we go to 8, we rise up and say, oh, look, it's 40 bucks. Or you could plug 8 into the equation. 8 times 10 is 80, minus 40 is the $40 profit. That's it, peeps, a sweet version of translating a word problem into slope-intercept form and graphing it.